webinar session. Today we're going to be covering tools for enterprise AI, PowerAI vision and data science experience. And I'm really pleased to have Chris Parsons deliver the session. You may have seen this advertised in two different ways. This is session 72 on the Power Virtual User Group, and it is also a virtual meetup on the IBM PowerAI London Meetup Group. So without further ado, over to you, Chris.
Excellent. Thank you, Jyoti. Yeah, so basically this is a sort of follow-on session, but I'm not going to assume any prior knowledge really. So if you haven't seen that first webinar, absolutely no need to worry. I'll kind of cover the basics and foundations where it's relevant in this session too. But just wanted to briefly talk through some of the challenges faced by data scientists today, and also some of the tooling that IBM have built to run on top of our infrastructure, to run on top of all those optimized frameworks that are included in PowerAI, to really make the process of doing data science, getting hands-on with this stuff, as easy as possible. So I'm just going to start by setting the scene. I've got a few slides that I wanted to run through about data science in practice. This deck, I'm going to start with a disclaimer. I'll hold my hands up, honestly say what's possible and what's not. Then talk about the format of data for doing data science, for doing machine learning, and then the process of transforming it. So how do I get that data from my raw data source into a format, into a usable way so that the machine can do something with it, so we can do machine learning and start to build this AI. Then I'll talk about options and alternatives, different things you might want to consider when you're looking at deploying this kind of solution, or different pitfalls that you can work around, and then next steps moving forward. And I'll leap then into a couple of live demos on DSX and AI vision, as Jyoti said. So DSX is our kind of platform for data science holistically, and AI vision, as the title suggests, is specifically for image and video analytics workloads. Okay, so disclaimer. I hear this question a lot, or I think this is an assumption people make when we start to talk about building and doing machine learning. There's this kind of assumption that the data you have, wherever that data is good to go. And all you need to do is somehow pipe that data in, wherever it is, pump that into your server, click the magic go button, and out the other side you get some AI. Now, believe you me, I wish that were the case. I wish it were that trivial to get from absolutely nowhere to having an AI just at the click of a button and just for feeding some data into the system. But, you know, as of today, we're not there. So this is the whole kind of role and remit of data scientists, is taking your enterprise data source, taking that large collection of, or maybe multiple data sources, maybe there's social media data in there as well, taking that kind of broad overarching collection of information that lots of companies hold, that lots of people hold, frankly, and then turning that into something that is machine readable, that the machine can understand and begin to process. So it's absolutely not the case that you can just hit the magic go button and suddenly build an AI. And that's true everywhere, by the way. But what I'm going to talk about here is some of the techniques that data scientists can use, or that you can use, to get from that standing start to having one of these solutions. But I just kind of wanted to put this up there as a disclaimer, and that is that there's no kind of silver bullet here in getting to the right answer. Now, we do have some tools that will make this a hell of a lot easier for you, but as I said, there's no magic bullet. Okay. So, what format does my data need to be in for machine learning? There's two fields, really. There's two kind of major themes in machine learning. The first is supervised learning. And this is kind of what most people will think of when they think of machine learning. And what we do is we hand our system a set of labeled data. So basically, it could be a collection of images, and we say all of these images are pictures of Dachshunds, all of these images are pictures of Shetland ponies, that kind of thing. So we label our data, and then we pass that labeled data to the machine. And we say, hey, do you know what, machine? We want you to build up a pattern. Tell me what those things with that label had in common. Now that's supervised learning because it's in essence, or what you are doing is supervising the computer, because you're essentially saying this is the right answer based on some historic data, and then you're asking it to learn. So that requires you to have some labeled data. And on this slide, I've got a few different ways you can label it. So you can either label the metadata, so the image metadata if you want it. You can have them in appropriate subfolders. So this is, and in fact the example I'm going to show you today is exactly like this. So you've got different subfolders for all the different categories. Or I've got another example of this today as well later on, is to take CSV data, so to take comma-separated values, essentially like a spreadsheet, and then use that as your, and then have one of the columns in that spreadsheet as your labels. So that's supervised learning, and supervised learning is, as I said, the first place you will start trying to implement machine learning AI solutions. But of course, there's an inherent challenge in that requires you to have some labeled data, some predefined known standards, which is fine if you've got some data scientists that can do that process, or if you're already working in a way that you know what label you want. So if you already categorize your customers buying Aquafresh or Colgate, or buying Power Systems, or buying Mainframe, whatever it might be, if you've already got that data in that sense, you're in a much stronger position. But there's an even larger group of people who don't necessarily have those labels. So they don't necessarily have that labeled data. So how can they get started? Well, that's the other field. That's unsupervised learning. So that's where we don't supervise the computer. We don't tell it what it's about to see before it sees it. We just pipe the data in and then have the computer build up its own picture, its own map. Unsupervised learning is sort of the holy grail of machine learning, because if you can do that, then you literally can just point your system at some data and it will learn some things from it, which is great if you're operating in that kind of space. Now, there are some workloads that already today sit quite nicely under unsupervised learning. Things like customer segmentation, so grouping customers together based on their spending habits, things like that. You don't necessarily need a label for, and we can already do quite well. But for the most part, what we're talking about is supervised learning and labeled data. And both of the examples I've got today are supervised learning. So once I've done that, once I've got my data in some kind of format, once I've got my labeled data, I then need to convert it into something that one of my machine learning frameworks can understand. So for TensorFlow, that's TF records. For Caffe, that's blobs. So I need to take my raw information, wherever it's stored, and convert it into the relevant framework. And again, this is all the role of a data scientist, to do this pre-work. Okay, so I've got my data, and I need to get it into a state that my machine can understand to do machine learning. So this is, you have to imagine, if you will, that this is my typical enterprise data. What you see on the left is exactly how my enterprise is storing data, because it makes sense for people. So I've got my SQL database, and I've got two columns in it. The first column is the animal. The second is what type of animal it is, its classification. So duck, beaver, or walrus. Now that's fine, right? Because for humans, that's really easy to understand. I can see the value column, and if it says duck, I can map that to a picture of duck. That's fine. I can do that really easily. So that's how people think. And actually, that might be how I commonly hold my enterprise data. The problem is, computers don't think like that. Computers don't have an understanding of duckness or what it means to be a beaver inherently. They don't have that, right? So how do we get around that? How do we convert that into something the computers do understand? Well, computers understand binary really well. I feel like we all get that, right? Computers can understand if something is on or off. In fact, that's pretty much all they can understand. So what we do is we take our traditional data source like this, and we map it to this thing that you can see on the right-hand side here, this chart. And what we do here is we say, instead of having a value for each of the rows in our database, what we have is multiple columns that cover each potential value. So instead of having duck or walrus written in the value column, what we have is a separate column for duck, beaver, and walrus. And then we can just say true or false. So whether the animal is a duck or a beaver. And actually, that makes it much easier for our computer to understand. That makes it much easier for our computer to see what's going on, because it's just comparing true and false, which computers are really good at. So this is a typical challenge. I appreciate this example is not particularly typical, but one of the first challenges that data scientists will have is transforming the data into this kind of map that the machine learning algorithm could better understand. And actually, this process that you see on this slide here is called one-hot encoding. And there are tools that will do that for you built into the frameworks. But it's the first thing that you typically have to do. Now, it's also important to know what your data is, to know whether or not you want to do this. For instance, it makes sense here to do it because I've only got 3 potential categories. But if the category was something like address, I certainly wouldn't want to do this. Right? Because suddenly then my data gets better by its big, because everybody has every address possible and true or false in the right column. So it's about knowing what fields you can do this to, knowing what fields this kind of operation will perform improve your algorithm, and knowing what it won't. So you have to transform the data. Okay. But this assumes that there are no holes in my data. What happens if I've got a missing item in my data set? What happens if for some people in my data set I don't have their address, or I don't have their credit rating? I don't understand that particular feature. So that's another thing I have to do. I have to go through my data set, and I have to look at all the items in my data, and I have to decide how I'm going to handle missing data points. I'm going to handle null values. I have to come up with a different scheme for that based on the various columns. I might want to average all of the existing rows and put the average value in for the missing data. I might want to completely remove that column. I might want to completely remove that feature if I've got too many null values. I might want to add another value, say 0, that means null, and then everything with 0 in it, I know that I have a missing data point for, so I should handle or treat differently. But this is another thing you've got to consider, is going through and finding out what bits of data are missing and working out how you're going to handle them, how you're going to get around that. Okay, so I've transformed my data, I've got rid of my null values, I've put everything in a state where I can now do machine learning. I just need to click go on my computer. However, I've got another challenge, and it's the train test split. So you can see that kind of graphic on this slide that describes that. So if we take all my training data, all that historic information that I've been collecting, if I take all of my information that I know and I teach my computer, or I do machine learning on all of the data I have, which might seem intuitively like the right thing to do, because if you give it all the data as input, then surely that makes your algorithm better data, right? But that's not true, because if I teach it on everything, like, I can't test it on anything. Because if I train it on a data point, like I train it on an image of a cat, I can't then test it by showing it the same image of a cat, because it's already seen that. So that's cheating, right? So I have to split my data into 2 different categories. So I've got my training set, which is, say, 70% of my photos of cats, and my test set, which is 30% of my photos of cats, that I'm not going to train my model on. But once I've trained my system, I will test it on that 30%, my smaller group of cats, to see how well it performs, to see how well the system understands cats that it's never seen before, right? And that's how I'm going to get around that problem, and that's how I'll know how accurate my system is. So that's really powerful, because then I can concretely say how accurate my machine learning algorithm is. But every cat I remove from the training set and I put in the test set is a data point I've lost, is a data point that my system never gets to see. So it's a trade-off between being able to accurately measure your performance versus having enough training data to build something reasonable. Because if I put all my cats in the test set, then I don't train it on anything. So even though I could test it on 100 pictures of cats, I've trained it on none, it's going to be rubbish. So this kind of split, the train test split, is really important. It's really important to know where you're putting this and how you're going to balance it out. And actually, in practice, it'll probably involve a lot of trial and error. So why does that matter then? Why do I need to worry about transforming the data? Well, this is why you need to worry. I showed this slide in the previous talk, but basically what I wanted to just touch on here is that one of the big challenges around this sort of stuff is understanding what data you've got, what information is critical, and what you can afford to lose. So in this example, I've got an image that is 70,000 by 60,000 pixels. It's from a scanning electron microscope. It's of a collection of human cells. Then what we're looking for is those things with green boxes around. Those are the cancer cells, or those are the sites that would represent cancer. But the problem is this image is 70,000 by 60,000 pixels, which is massive, and that can be a challenge to process. So I've got a few different choices here. One, I drop the resolution of the image. If I drop the resolution of the image, I lose the information in it. And if I lose the information in it, then I potentially lose whether or not there's cancer in it. So I can't afford to do that. So I can't afford to drop the resolution. So my second choice is I kind of splice the image up into different boxes and then take each box and look in each box and decide whether or not there's cancer in each individual box, which again might work better than dropping the resolution, but actually is not necessarily the perfect solution because I might cut through one of the sites that I'm looking for and therefore miss it. So basically what I wanted to show with this slide is that actually it's important to consider how you transform the data based on what your data set is. Okay, so that's another consideration that your data scientists have to do. So hopefully what's happening now is it's building up a picture of actually this is quite a big challenge for the enterprise, for the business to work out how it's going to do this, because there's so many different facets to consider. There's so many different elements going on. How do you build a proper map of what's going on in your data and what I should do machine learning on and what I shouldn't? So with that, I'm going to move into some of the different technical choices you could make. So if we've got a big kind of data set, we might want to send it to multiple different servers for computation. That's what I can do here. And then distributing my workload across multiple different nodes means that I get insight back about each of those different segments of the image, right? And that could seem like a good way of solving it. But again, it's about understanding what your data shows you and working out what it's best to do with that data element. Which brings me nicely onto the live demos, you'll be pleased to know. So how do I govern all of this? How do I govern this monumental challenge of curating my data sets, knowing what's going on under the covers, understanding what pre-processing's been done on my data, what other data scientists have done to my data, you know, what columns they've removed, what columns they've dealt with null values in it, how they've sliced up my images if they're big images. How do I get around all that? Well, we've got tools for that. We've built DSX, or the Data Science Experience, which is available both as a cloud service and also on-premise, running on power systems. If you're trying to do things, you know, at scale with colossal amounts of enterprise data, we can provide this same tooling. And it's all about putting that governance around your AI. It's about building in the due diligence, building in that sense of what's going on in the environment, what's going on across my entire enterprise, and giving the entire enterprise access to the same tool chain. So it doesn't matter what facet you're in, whether I work in engineering or whether I work in product development or whether I work in HR, it doesn't matter what bit of the business I sit in, what vertical I sit in, it's about having a common tool chain that provides that governance around data science. And it takes all those data science tools that your typical data scientist will use to do that machine learning, like I was going through on the previous slides, to do that data science, and it puts them all in one place. Okay. And with that, I am going to leap into the live demo. But just before I do, I will actually pause quickly now and see if there are questions. Are there any questions in the chat, Josie? I will take silence as no. Okay, great. So, data science experience then. If you go to datascience.ibm.com, you can sign up for IBM Data Science Experience in in our, oh, let me close the chat, you can sign up for Data Science Experience, and it will give you access to a cloud-based instance of this. Now, it is available on-prem, as I said, on Power Systems, and it looks exactly like this. Can I just check that everyone can see my web browser?
Yes, well, I can, and I'm sorry I couldn't unmute
Everyone else
myself
is.
earlier. There are no questions.
Wonderful. Okay.
Well,
I hope that's a good sign. Great. So this is Data Science Experience, and as I said, it's about having that common tool chain, right? So we've got this. It's a browser-based interface, whether it's in the cloud or it's on-prem, so you get the same experience no matter how you're interacting with it. And it's about having, as I said, this common theme all the way through. So no matter where your data scientists are used to working, what platforms they're used to working on, they get that kind of common feel all the way through. So I've got a project here that I've already created, but what I'm going to do is I'm going to be really brave, and I'm going to create a new project here and hope it works. And if it doesn't, I will default straight back to the one that already exists. Let me give this a name. So I come up with my project name, and this could be anything, just whatever I'm working on in the business. So there's going to be lots of different projects going on. So I might have some people doing customer segmentation, some people trying to recognize, what photos there are or whether or not people are wearing PPE. Whatever it is within my business, I can have multiple different projects, and I can manage them all here. So I'm just going to click Create. And it's going to go ahead and it's going to build that project. You'll notice over here on the right-hand side, I've also defined the Cloud Object Storage instance and the Spark Compute instance I'm going to use. And that's critical because in the cloud, I'm just using the default instance that I spun up for this. But actually, on-premise, that would mean that I can have different people in my organization having access to different clusters, all managed through one interface. So I might decide that engineering is actually more critical than somebody else over here, and I can provide them access to different groups and still keep this kind of common tool chain. Okay, so what I'm going to do now is, so this is my project. So on here I can see I've got my overview, which tells me how much storage is used, who's collaborating on this project, so what data scientists, what engineers are involved. I can see my deployments, that kind of thing. I've got settings, so I can manage the settings in the project. And also, I know there isn't anything at the moment because we haven't done anything. I can also see recent activity. So while I'm offline, while I'm not working, say I take a week's holiday, for instance, I come back and I get to see what changed. I get to see what work's been done in that time I was missing. So on the Assets tab, here we go, I can see different types of assets. So the top asset is my data sets. So that's what data I have access to. Now, of course, that can be a connection to some other data in my environment, or it can be some data that I upload and it will store in the Cloud Object Storage, or it'll store on my infrastructure for me at the time of computation. I've got notebooks. So notebooks are the typical data science development environment, and I'll show you that in a second. But the first thing I need to do, because I want to do some machine learning, I want to do some data science, is load in my data set. So what I'm going to do is I'm going to just come out of this, and I'm going to drag and drop. So this is all available on GitHub, by the way. There's a link to it in a second. But I just want to show you how easy this is. So this is my data set that I've been working on my computer, and now my enterprise has decided that we're going to use DSX. So I need to upload it to this. I'm going to drag and drop, and it says pending, and that uploads. And it's that simple. So now my data set that my rogue data scientist working in Shadow IT was working on his laptop is now shared. It's now collaborative. So other members of this project, other collaborators on this project can have access to it, and they can help work with me on that data science. Of course, we can view the data set in its entirety if we want, so we can see the actual data set here. This data set, just as a bit of background, is a data set of passengers that traveled on the Titanic, and it's a status based on whether or not they survived the disaster. And what we're going to do over the next sort of 5-10 minutes or so is build a model, do some machine learning on this data set, and understand if we can build a model that will determine, based on just the passengers' information, so their age, gender, that kind of thing, whether or not they survived the disaster. Okay, so that's that. That's our data uploaded. Brilliant. That was super easy. Of course, we could have easily made a connection to our existing data store if it was bigger than that small CSV, but just for this demo, I've kept things kind of contained. Okay, so the next thing that I'm going to want to do is create that development environment. And actually, I want to do some fancy things in my development environment, so I want to take a Python script that's going to help me with some of the visualization. So I'm going to create a new notebook. I'm going to create a new blank notebook, and I'm going to call it Visuals Notebook. There we go. It came up for me because I've done this before. And down here, I can choose my language, right? So again, it's about just creating a platform for whatever your data scientists are using, whatever your teams are using, and bringing it all into one place. So if I use Python 2, that's available. If I use R, which is, again, really popular in machine learning, I can select that too. And we've got Scala there as well. And if I'm an adventurous enterprise, I can use Python 3.5 as well. I can be on the latest and greatest version. But of course, most people are using Python 2. I certainly am, so that's what I'm going to stick with. Okay, so the next thing I need to do is create my notebook. Bear with it a second. This is a good advert for buying it on-prem, by the way. There we go.
Well,
yes.
Oh, okay, I was going to say there's a question perhaps while you're waiting for that. So how is cloud object storage different from a file system storage? Kieran is asking.
Yeah, good question. And I will dive into that, but not at this point. I'll just carry on and finish the demo while my train of thought is going, and then I'll come back into how cloud object storage and that varies. But actually, that's a really good point, and I will cover off the architecture and why you might want to use the cloud and do things with cloud object storage, or do things on-prem, or the differences between the product. But for now, if you just trust me that they look and feel the same, and the process is the same, and I'll dive into that at the end. Is that okay?
Thank you.
No worries. So here now I'm on GitHub. It's my GitHub, and I'll make sure the link is shared afterwards, so you can all do this for yourselves after this webinar if you want. And what I'm going to do is, that's not the best way to do this, is I'm going to copy this script here. This script is called visuals.py. I'm going to copy it into this notebook. But at the top, what I want is because I want to write this to a file. So that I can access it from my other environments. So I've just pasted that code in from GitHub. Yes, I appreciate that was a bit copy-pasty, but I just want to show you that there are multiple ways to do this. So the first is creating files from scratch. I'm now going to execute this notebook. There we go. And it's written visuals.py to my environment, so everyone can access that. So that's one way of doing it. And that will give me all of the tooling I need to visualize my data. We just have to wait a minute for that to finish. There we go. So I'm going back to my webinar project now. And now look, I've got my visual notebook. I can see when it was last edited. I could see what edits they'd made. I can also go in and make comments on it, but I'll show you that again in a second. I just want to get into the nitty-gritty data science stuff for now. So now we've got the visualization tools, we've got the data science uploaded. What I want to do is create a new notebook that I'm actually going to do my data science in, that my team are actually going to start manipulating that data in. So I'm going to create a new notebook. But this notebook, I'm going to have from a URL. So instead of having to do that copy-paste business, I'm going to assume that my company uses GitHub or uses some kind of tooling like that to manage their code so that everything's under version control. It's got all that due diligence around it. And I'm just going to paste that in. So I'm going to paste that URL in, and let's call it Titanic Demo, and I'm going to create the notebook. So now DSX is going to integrate with GitHub. It's going to integrate with that code and pull that notebook that's stored in my shared file system that we've been collaborating on it before with all that version control in it. It's going to pull all that stuff in. As you can see, it's done it, and put it within DSX. So I'm going to get that in my shared environment. So here we are. This is the kind of the demo environment. Now, this notebook, because my data scientist before was doing it on their desktop, this notebook assumes that you're going to read a file in that's in the same directory. But of course, we're not going to do that anymore because things have changed. So how easy is it for data scientists with this tool to manage where their data sets are, to always have the latest version of data sets, to have that due diligence? Well, it's this easy. All I have to do is replace this code, which reads the file in, with some code that actually DSX is going to generate for me. So I go up here to this code button, and I click on Files. Of course, I've only got one file because I've only got the one data set, and I click Insert to Code. And I want to create the pandas data frame. And that's it. That's all my code. That's all I need to do. And that connects via API key to this environment, to that data set of Titanic survivors, to that database, and pulls it all in. And then if I can delete these lines now because I don't need those, and I'm just going to rename this full data because that's what it's called later on, and delete this line, and it's done. That's it. That's it. That's all I needed to do. That's given me everything that I need there. So that's that connection made to that data I uploaded. So now if I click Run, what will happen is it'll display the first 5 rows of that data. So there they are. And there's, in this notebook, if you look at it yourselves, there's lots of kind of description of what's going on, what these different columns mean. But this is our data. So this is our data loaded in. And we can see here we've got different features, whether or not they survived, their socioeconomic class, what their name was, their gender, their age. So SIB-SP, this is how many siblings or spouses they were traveling with. PARCH, or P-ARCH, is how many parents or children they were traveling with. Then we've got their ticket number, how much they spent, what cabin they traveled in, and where they embarked. So what port they got on, whether it's Southampton or Queenstown or wherever that was. So as you can see here, I've got a better description of what's going on in each of those columns. Now, this is interesting, right? Because remember I was talking about supervised learning where we need a label of our data. Well, in this case, the label of our data is this column, survived, right? But we need to take that out because at the moment it's mixed in with all our data. And we need to take the label out of our data so we can start to do some machine learning with it. Because if it's in there, we can build a model and it's super easy for it to predict whether or not they survived because it'll just look at the survived column and tell us what that said. But we want to make it slightly more challenging than that. We want to do it based on the raw unlabeled data. So we need to take the survived column out, which is what this next code cell does. So you can see from the graph below, what happens when I run this is we take out that survived column and we leave all of the other columns untouched. Okay, so that's separated our label from our features, from our input features, and we've got them in 2 distinct categories. Okay, so that's the 2 separated. The next thing that we need to do is define this function, which is going to measure how accurate our models are. So what this is going to do is when we make predictions, when we build a model and we make predictions based on whether or not somebody survived, what we're going to do is in this function, we're going to see if the predicted value is the same as the actual value. And then if it is, we're going to report that as a percentage. Or we're going to report the percentage of them for which that was true. So I'm going to run that, and that's just going to build the function. Okay, so now let's actually start to do some data science. Let's actually start to get involved in the nitty-gritty. So let's assume then, for a minute, let's see, I mean, the accuracy is there, which is kind of a spoiler, but let's assume for a minute that we're going to build a model that is going to assume that the passenger didn't survive. It's just going to always say that whatever passenger it is, they didn't survive, right? I'm just going to execute this now so we can see its accuracy. There we go. The accuracy of that model that just predicts that they didn't survive is 61% accurate, right? So without doing any machine learning, if we build a really naive system that doesn't look at any of the data, that doesn't do any learning, and just has it predict that the passenger didn't survive, it's 61% accuracy. It's 61% accurate. But let's see if we can use some kind of visualization to get a better understanding of what's going on in that data set. So I'm just going to, so here in this next cell, what I've done is I've visualized whether or not they survived. So over here, we've got two different columns. One is the gender, and then whether or not they survive. So here it shows us something massive, right? It shows us that actually if the passengers are male, they're much less likely to survive. I mean, a few did. There is a portion that did, but they're much less likely to survive. So let's dive a bit deeper into that. Let's go a bit under the covers and see if there's anything we can kind of determine about that, to look at that in some more detail. So here we can see, if we plot the age with whether or not they survived, actually we can see that males under the age of 10 did survive. And it was the older males that didn't survive the disaster. So let's look. So if we build a model that takes that into account, right? So it assumes that if you're a female passenger, you survived, and then if you were a male passenger under 10, you survived. Let's build that model now, and otherwise you didn't. So that looks a bit like this, right? So that looks a bit like this. I'm just going to run this again. So we get to about 79% accuracy, so approximately 80% accuracy, just making those assumptions, right? But I know what you're thinking is, so far, we've not actually done any machine learning. It's just been data science. We've just been going through the data and building up this mental picture of the data manually, right? Can the computer beat us? So let's start to bring some machine learning in then. So this is, we're using sklearn here, which is a common data science toolkit, and we're getting this tool to go through and build that classifier for us. So we're not telling it to look at male or female or any of the genders. We're telling it to look at all those features and build up a map. Let's see how accurate that is. Okay, so it's 73%. So that's a backward step, right? So the machine's actually doing less well than us. Why is that? Why is the machine not as good at understanding the data as we are? Well, we have to understand what the machine's doing. And at this point, the machine is looking at everything holistically, and it's trying to include all the data, and we've made no optimization, right? We've not flattened any of our data. We've not handled null values intelligently, particularly. We're not even using a particularly good classifier. We've just pointed the machine at our data, right? So you have to make a leap with me now. I did try this. I tried various different techniques to see which ones were best. But once you start to do that tuning and improve your algorithm, then you can get to a position where you can build a much more accurate model. And here you go. At the bottom here, we've got one that gets to about 80% accuracy. So once you start to pick better models, you can really bump that accuracy. And actually, I've left it as a bit of a challenge to anybody watching this webinar to go out and try and beat that 79.82% accuracy. So to look at different machine learning techniques, to look at the documentation and improve this notebook. I'll make sure the email gets sent round to change that to see if you can beat that accuracy, just as a bit of fun. But fundamentally, that's the challenge that we're looking at. So that's the end-to-end workflow of doing some data science. So we've now built that model. But of course, this is more about the tooling. So what else does this tool show? Well, in the assets, you'll remember, just loading them now, I've got these two different notebooks. Now, if I click on the pencil, it will edit the notebook, and I'm the one editing it. But actually, this is more about the collaboration, the governance. So how can people collaborate on this? Well, this is how. So this here is loading up the notebook in the collaboration view. So here I can see all the notebook. I can see all the work that my colleague's done. Look, he's gone through this. He's built a brilliant model. But actually, I want to add a comment like, why don't you try a neural network post, right? And other people collaborating on this notebook can see that. So other collaborators will be notified about my comment, and they can come in and read this. And it acts like a discussion around that, so we can comment and share and help each other in the same team improve and collaborate on our notebooks. Okay, so it's all about bringing all that stuff together. So we've got the option to download these notebooks to start to do some offline stuff. We can share them with other members in our team. We can schedule review calls and stuff like that. So if we want to talk about the work that we're doing, we can do all that from this one place. And of course, we can get help down here in this chat box. We can get help right from one portal. So it's about bringing everything together. So whether or not what the environment behind the covers supports this platform and makes this platform run much faster, but it's about kind of building that holistic view of the world. So you've got the enterprise governance, the version control, the due diligence around the data, the single collaborative portal in one place. And that's what data science experience gives you. And if you remember back to that presentation that I started this call with, this is the major challenge for data scientists, is going through the data, understanding what the information means and cleaning it up. And here we've got a portal that lets them use all of the tools they're used to using and bring them under one roof, bring them under one tool chain and collaborate together to make that happen. And what that ultimately means for your enterprise is that the AI that you build, not only can you can demonstrate how it does what it does or how you built it, the process you went to build it through, you also know that the engineers that built it had the time and the tooling they needed to collaborate on each other and will generate better work product as a result. So it's about kind of bringing that together. And of course, as I discussed in the other webinar, this runs on top of PowerAI so that you get all of that goodness, all of that accelerated stuff and the performance boost provided by the infrastructure under the covers. So it's about doing this at enterprise scale, but with all that governance wrapped in around it. So that's DSX. And that's great if what you want to do is to use this sort of CSV data to do things using the traditional Python notebooks and stuff like that to go through things end to end. This is a brilliant tool. And I could spend a full hour going through the features of this. But there's something else I want to show you. There's another tool we've built, and this is called AI Vision. So this is my AI Vision instance. And AI Vision thinks at things a bit differently. So AI Vision kind of flips the paradigm on its head. So instead of creating a platform for data scientists, what AI Vision does is create a data science platform for subject matter experts, right? And that makes a lot of sense, because if I think about my typical image recognition workload or image classification workload, let's look at it like medical X-ray scans, like the cancer detection image I showed you earlier on. If I take those varying different workloads and I bring those together, at the moment, what I have to do is take my chest X-rays or take my cancer scans and put them, and I need to train a data scientist to recognize different types of cancer, then get that data scientist to label the data, and then get that data scientist to build a model of that information, then deploy that model into my production environment, and then I start to benefit from it. That's not what I want to do. I want the person that builds that data set, that curates the data set cancer images, to be the expert. I want it to be the doctor that really understands cancer images. I want it to be, it doesn't matter, it doesn't need to be medicine. I want it to be the guy working on the manufacturing line of my plant who's an expert at spotting defects, right? He can spot defects in less than a minute of cars or whatever the vehicles are or whatever the objects are rolling off my production line. So he's a real expert in that. He's not a data scientist. I want him to be the guy that classifies images that are going to go into my model, right? I want it to be the subject matter expert. And PowerAI Vision is all about putting the data science task back in the hands of the subject matter expert.
Chris?
So, yes.
Sorry, before you carry on with the PowerAI Vision, there were a few questions. I wonder if it's a good time to handle those before we move on.
Yeah, for sure. Let's go.
Okay, so Andrew Laidlow, thank you very much. He's answered some questions on the object storage that was asked earlier. One of the questions that came up was, do we need to write these functions or are they available in the kit? That's when you were talking about data science experience towards the end.
So some of the accuracy stuff, some of the stuff like that. Yeah, so for the, okay. So it depends. A lot of them are included. So I wrote my own accuracy function so you could see what was going on under the covers. There is one included in scikit-learn. At the end of, in fact, if I flip back to the notebook. So here, let's go down. So these functions that I was writing, you have to write those because I'm writing these based on the data as it comes in. The accuracy score function, there is one of those included. I didn't need to write that, but I did write it because I wanted to show you guys what was going on under the covers. These, as you can see, is just making a simple function call to survival stats that renders this graph. So that, again, is provided by the visuals.py library that we imported earlier on. So some of the functions are there, others you have to write yourself. Now, all this stuff, where we start to, let me scroll to the bottom, all this stuff where I start to actually do machine learning, I don't need to write myself. As you can see here, it's sort of 5, 6 lines of code to build a gradient boosting classifier, fit it to my data with this, this line here, and then do my predictions and test against my accuracy score function. So loads of it's included. Loads of it's included in the data science toolkit. Some of it you do have to write yourself when you start to do manual manipulation, when you start to try and clean up the data, but lots of it's included too. And I guess that's the point, right? That's the challenge that the data scientists are facing, is that yes, they have to write this code, but at the moment it's all in disparate bits of the organization, it's different people doing it. Data science experience is about bringing that all together. So if my mate in a different team has written a really great accuracy function, I can use his code. And that saves me time. I hope that answers that question.
Mm-hmm. There's a couple more. So,
Sure.
How does the user interface break the Titanic demo file into runnable sections to show the results and the comment block? For example, the results grid and comments like awesome. So now we've got our features labels. So you had different
okay, yeah, I see what you're saying. So how have I got these different things here? So this is actually a Jupyter notebook, or used to be an IPython notebook, if anybody's familiar with those. So Jupyter notebooks are really common in data science. They're because they let you do that. Let me open this in edit mode a second, and I'll show you how I did it. But basically, it's a feature of Jupyter notebooks, and DSX also enables that tooling. So here I've got my text. If I double click on this, it turns into Markdown, which is like a syntax highlighting type thing. So I can change this to, I hope this answers the question, and click run, and it changes. So then this appears as static text, but I can go in and edit it. And it lets me create those inline comments. So all I have to do is change the format of the cell here. So at the moment this is code because I'm writing code in it, but I've got multiple different formats here. So I've got Markdown, I've got raw content, I could have headings. So it's just about creating that visual way of doing data science. But yeah, great question.
Okay, thank you. And then another question is, was there a code snippet to specify how to arrive at a yes/no answer, whether the Titanic passenger survived?
For the models I built. So yeah, there was. So here it is. I kind of skipped over this. So again, this is all on GitHub, so you can root through what I've done and feel free to ask as many questions as they come up as you dig through. But yeah, so basically this function here, this two-feature model that I've just highlighted, does exactly as you've just described. So what we do here is we iterate over every passenger in our data, in our features, and then if they were female, we predicted they survived. If they were under 10, we predicted they survived. Otherwise, we predicted they didn't survive. And then we just return that predicted values array. So that's kind of how we did that in the non-machine learning example. Great questions, though.
Thank you.
Any more?
So that's it for now in terms of questions. I just wanted to ask the people who've joined today's webinar whether they joined via the Power Virtual User Group or the PowerAI London Meetup group. So if you wouldn't mind typing in to the chat window which method you've learned about this webinar from, which group, or if you're a member of both and you've got it from both sides, I'd be very grateful. Thank you.
Yeah, thank you very much. That's a good point. I mean, I'm sorry we can't do it in a proper poll. If you joined early, you would have heard Jotty and me debating how on earth we were going to do that as a poll, but it turns out it's much easier just to ask the question of you guys. But just to help us work out what we're, or where we should, I guess, shout about these kind of webinar stuff like this. But yeah, please keep the questions coming in. These are great questions. And as I said, I'll make sure a link gets distributed, or if I switch to this tab now, there we go, the link at the top, github.com/ChrisParsonsDev/DSX_Titanic_demo, and you'll get all the code. that I put together. In fact, I've even included the data set there for you. So feel free to root all through that, try and DSX yourselves, whatever you'd like, really. And I'm happy to help guide you through stuff, answer questions as they come up. But brilliant questions so far. Please keep them coming in. Okay.
Thank you, Chris. Yes, carry on.
No worries. So now back to the SMEs, right? I mean, as interesting as those data science questions were, what happens to my guy that just wants to build a model and doesn't want to do all that nitty-gritty data science? Well, we hear you too, right? So we've got this platform called PowerAI Vision. It's brilliantly titled because it sits on top of PowerAI and it does vision workloads, be the video or image. And what I'm going to do is walk you through end-to-end the process of creating a model doing this. So if you remember back to the first webinar, I went through that worked example of doing handwritten single-digit, that example, the MNIST example. Well, as the hello world of machine learning, well, it's back, you'll be pleased to know, in this sort of sequel. So here's my data set. And what I've got is all these different categories. So they're single digit. So MNIST is the data set of 65,000 handwritten single digit numbers. So these are all my zeros. Look, I can view the original if I want. They're tiny, by the way. Or I can remove them from the data set. So I can manage my data set from this place. So instead of all that code that I was writing in DSX to handle the Titanic data, this for image recognition is a user interface with some clickable buttons. So you can put it back in front of your doctor or your engineering lead or whoever it might be, your subject matter expert, and get them to do the data science. And how powerful is that for an organization, right? And you can see they're all here. So look, 1 is full of ones, and I'll pick randomly. 6 is full of the number 6s predictively. So it's that easy to manage data sets. I can simply add a new category. So let's say I want 10 to be included. I can add the category 10. There it appears. And I could add the images of the number 10 there, and suddenly my model can handle 0 to 9 and then 10. I'm going to remove that category because I don't want it there. Okay, so that's how I curate my data set. And making a new one is as easy as going up here. So this is my datasets tab. I've got loads of other ones here. So this is, I go to add dataset, and then I can pick what category it is. So if I'm doing image classification, which is MNIST, so I want to classify it as a 0, a 1, or a 2. Or if I want to do object detection, which is tell me where in the image there is a 0, a 1, a 2, a 3, whatever it might be. Or if I want to upload it from a zip file from my laptop, I can do that too. And AI Vision even handles video data, which is like the holy grail because that's kind of next level stuff. It's really tricky to manage your video data sets. Again, we can do it all from this one interface and it looks and feels exactly the same. So I could go add a data set for image classification. Then I pick a scenario. Now what the scenario does is behind the scenes, under the covers, that modifies the algorithm that AI Vision will use to categorize that data. So we've got slightly enhanced algorithms for certain data sets, obscurely, specifically Chinese food. But basically there's a list of categories and you can choose the one that kind of best fits your data set. I tend to go with others because I'm not often classifying Chinese food. Maybe I should think about it. Or the human face, or whatever it might be. But you can use that to tune the algorithm when it gets there. So you just pick whatever category you want, and you give your data set a name. Let's go, hello, webinar. There we go. And add my data set. So that's my data set created. And then I can go and add different categories. So this can be cat 1. There we go. And I just upload the pictures, either by selecting select sum, or just dragging and dropping them. So it's super easy to use this interface. Like I hope it comes across as I walk you through this now. This could not be easier to use. Okay, so that's my data set created. Now I want to do some machine learning, right? So presumably things get harder here. Well, they don't. So I go to my second tab in my workflow, and I've got my deep learning tasks. And what I can do is go create new task. Yeah, I want to do image classification on the MNIST dataset, and I want it to be speed first because I don't want it to take too long, and let's call this webinar test and build my model. Now it might take 1 minute. So I'm going to kick this off now. So now what happens again, I've written no code. I've done no nitty-gritty Python stuff. I've got no Jupyter Notebooks. I've clicked on a few buttons. And what's happening now is PowerAI Vision is going through all 65,000 images, and it's pre-processing them. So it's making sure that they're all the same size, they're all the same height and width, they're all using the same color channels, so they're all grayscale, they're all appropriately formatted. There's none in there that are sort of 4K images and others that are hideous images that were taken on a really old mobile phone. It makes sure that everything is in the correct format to give the AI the best chance of doing what it does. So we'll see that once this happens, it moves to the status training, and we'll see in a minute it plots some visualizations for us. There we go, look. So it's only going to do 100 iterations. So it's only going to walk through the data 100 times. You can see how quickly it's doing that, right? It's walking through 65,000 images in the blink of an eye, 100 times. And as you can see, it doesn't get that accurate because we're not walking through the data many times, but I just wanted to show you this process end to end, which is why I've included this. I know this isn't going to be world-beatingly accurate, but I just wanted to demonstrate the whole workflow end to end. So estimated time after 0 seconds, so that's completed, and I can scroll down, and down here I've got deploy and test, right? So now I've built my data set, I've built my model of my data set, and I've got a deploy and test button, so I can deploy it. I can deploy my AI, right? Still written no code. I've still had no data science skills. I've had to do nothing behind the scenes. I've been using this really simple, easy to use browser interface. Okay, so this model, I could deploy and test it right from here, but I'm not going to because, as I said, the accuracy on this one's not great because it was a quick test. But if I go to my trained models, you'll see one that I did earlier on, cheekily, at 8:40 this morning, that was 97% accurate. And it did take a bit longer to complete. It took nearly 6 minutes to complete. Obviously, I didn't want to keep you guys waiting for the full 6 minutes on this webinar, which is why I cut that corner. But here's my model, right? So it's listed here. I can see what it was. I can see what time I trained it. And now I need to deploy it. But I don't have any software engineering skills. So how do I take that model? How do I take that code and deploy it? Well, if I did have software engineering skills, I could export the model as a zip file, and that gives me all of the, so that gives me the labels file, that gives me the weights, that gives me the underlying model for this image classification task as 3 separate files, and then I could do what I wanted with them. I could deploy them in the cloud, I could deploy them into an iOS app, I could put them on an Android app, I could put them on a desktop application, I could do what I wanted with them. So you can get the models out. However, this is about how easy it is to do. I don't want to go into the kind of nuts and bolts stuff. I want to just click a button and it work. I can click deploy, and then it comes up saying, well, do you want to deploy such and such an API as a web API? And I think, yes, I do want to do that, yeah. So now what's going to happen is AI Vision is automatically going to deploy that model as an API for me. It takes a bit of time. There we go. That's how long it takes. And that's it. It's deployed it. It's deployed that web API. I'm just going to come back out of full screen mode because I want to have access to my files and folders. And it's that simple. So now I've taken my data set. So I've curated my data set. I've built a model for that data. I've deployed it as a web API. And it's happened in, what, 5 minutes? And I've written no code. So if I go into here, MNIST, and then testing. So do you remember I was talking about training and testing? Remember I was talking about training and testing earlier on? Well, I've got 2 separate folders. So the folder that I trained it on, I promise you, was these images in training. But in this testing folder, I've got another subset of data that my model has never seen before as training data. So I'm going to randomly go in here and pick this number 4 and drop it on here, and it's going to classify it, and it tells me that it's 99% confident over here that that was the number 4. That's how simple it is. To go end to end, to build image recognition models, to do really complex tasks without the heavy data science bit, if that's what you want to do. And that helps me, because that means that I can put the data science back in the hands of the subject matter expert. And this is kind of our focus, right? Our focus is on providing that software level with data science experience, with AI vision, It's about providing that software tooling and the software tool chain to kind of activate, to kind of build these models, to get this stuff deployed, so that as an organization, you can get running really quickly with this stuff. And it puts the governance around it as well. So not only do we have, in my opinion, the best platform for running these workloads, but also we've got the groundbreaking software tool chain that sits on top of it that makes it easy to get the best out of the tin. And I think that's kind of what we're all about here, really. And with that, I will kind of head back to questions. Jyoti, are there any?
Thank you, Chris. At the moment, there are no new questions that I can... Oh, there's one just popped up. What is the color contoured image next to that of the number 4?
Yeah, awesome. I mean, the questions have been fantastic, guys. Definitely keep them coming in. So this image here is what, this is a graph of the activations. So when we build that model, and it builds that model, and it comes up with, if you remember back to the previous webinar, like a heat map of what those different numbers see. That kind of the red and blue heat map of the various different numbers, what the nth term rule is. This graph here, the colored contour image, is what activated. So this here shows why our model thought it was a number 4. So it activated down here in this kind of region and up at the top, and it felt that that made it a number 4. Things might get a bit clearer. Let me upload another image. Let me go to 0, and let's pick this one and drop it in. Okay, so here the colored contour image has changed, and it's activated in this section. So the absence of anything in the middle of the image, and then like a circle of white stuff, is why it was completely confident that it was a 0. Yeah, I hope that kind of makes sense. What other numbers will be good for it? 3, I think, to show that. Let's pick this one. There we go. So 3, it's activated again here in the middle. This section where it looks a bit like an M turned 90 degrees is why it activated. So this is a really powerful diagnostic tool because it shows us what regions of the image caused our model to predict it as a 3, a 0, or a 4. And that's really useful for understanding why your model made the prediction it's making. And actually, you can quickly use this to diagnose whether or not your model is doing what you think it was doing. Heard stories of customers that had models that they thought were fantastic at recognizing different products, but it turned out all their model was doing was making predictions based on the background color, right? Which is not what they wanted to predict at all. But this little heat map here, those colors showed that it was the background that was activating and not the image at all. And that really quickly let them realize that actually what they needed to do was change their data, go through and take the backgrounds out of their data set and retrain their model to get something better. So that's what that shows.
There is another question about the support for PowerAI. So the new PowerAI version 1.5 is supported on Red Hat 7.4 only at the moment, but this particular person, Reinhold, is running PowerAI on Ubuntu. Mm-hmm. So the question is, does PowerAI 1.5, will that be supported for Ubuntu, and if so, when? Okay, so
currently 1.5 is Red Hat only. I think that the plan is for subsequent releases to be available on both at parity. So for the next generation, we should see both operating systems.
Great. If there are any other questions, please type them into the chat window. I don't see any new ones at the moment.
Okay. Well, I'm sort of out of demo. So if I hand back to you for kind of the final few slides that you wanted to share, Jyoti.
Sure. Let me just take control. So if there are any questions, then please do type them into the chat window, and I'll cover in a moment. I'll put up the slide that okay, I think Chris, I don't have the sharing back. I don't know if you have to.
I'll pass the ball to you.
Okay.
Has it come up?
The ball has, but okay, I was in the wrong page. Getting there. Okay, so you should be able to see today's session was what we've just covered, but on the Power Virtual User Group, the next session coming up is on the 7th of March, which is going to cover HMC and Cognitive Systems Management Update, and Ashok will be covering that. He's been a speaker in a previous session. And on the 11th of April, there's an IBMI-related session covering REST APIs and IBMI and Watson, so which may be of interest to you. And then on the 23rd of May, we're back with the AI theme, and we've got to confirm this yet, but the idea is that Chris will come back and actually show us how to build a PowerAI Vision application. So that's what's in plan. As I mentioned earlier in the session at the beginning, this particular webinar was run as a joint session for also the PowerAI London meetup group as a virtual meetup. So if you're interested in joining that, please go to the URL at the top of the page. If I just show you the meetup group, you can go to meetup.com and search on IBM PowerAI. You will find that there are different meetup groups all over. So not just London, there's some in Manchester and Bristol if you're in the UK, and then across Europe in Munich, Frankfurt, Paris, Milan, and so on. So that's a way to join up local communities. And going back to my slide, you may also be interested in another live online session that we're running on the 7th of March. You may be aware that yesterday IBM made some announcements in Power Systems. We brought out some new Power 9 servers. So please join us on the live stream on the 7th of March to hear more about it. And just showing you another slide, and I'll include the information in an email that I sent to you with the replay links, the announcement letters for the different servers that we've just announced. And that is it. I hope that you can join us for the next session on the Power Virtual User Group, which is on the 7th of March. And I hope that you'll be able to come and meet us on our meetup group. The next session is being planned for April as a face-to-face session on the London meetup group. We're just finalizing some details for that. Okay, let me just see if there's any more questions.
There are a couple, which I tried to answer, but it dawns on me I just sent the message straight back to you, Jyoti, because I'm not brilliant at this. So, Kieran, is it possible to write code for or who writes the code for identifying similarities of all the training set data? That's us. That's included in the PowerAI Vision software tool. What we're doing under the covers is transfer learning to build, to take an existing neural network and then apply new weights and biases to tune it to the images you're uploading. And then the second question was, is it possible to check a live image? Absolutely. Once you've deployed it, you've got a web API. You can interact with that via any of the REST protocols, so GET or POST, to classify a new image. So that's how you could send an image up from, say, a mobile app, for instance, or wherever it was captured and then sent to the device. The other thing that we can do in AI Vision, I've not demoed it today, but as part of the video data platform, is take video footage and build a trained model that will classify and categorize data from streamed input, from video input.
Okay. Any more questions? I don't see any on the chat. Any sent to you, Chris, privately in your chat?
Nope.
Okay. Sounds good. So regarding your GitHub URL that you were going to include, I can put that on the wiki page and also include it in the information we send out with the replay links, both as emails and on the meetup group.
Perfect.
Great. Well, if there are no more, yeah, you've just put the GitHub link, so that's great, into the chat window. Okay. Let me stop the recording. Thank you all very much for joining. I will catch you next